Students, in this lecture we see the next type of the integral, that is integrals of linear function upon under root quadratic function. Here, linear function upon under root quadratic function. Here we have already learned in the last lecture, it is a linear function upon quadratic function. See carefully here, integral of linear function upon quadratic function. Here, and the solution method of this quadratic function here, it is a linear function, can be expressed in the a into derivative of quadratic function plus b, where capital A and capital B are the constants. Okay, now in this lecture we see it is a linear function upon under root quadratic function, and the process is same as a linear function upon quadratic function. Here again solution method, it is a linear function which is a linear function, it is a px plus q is equal to a into derivative of quadratic function, that is ax square plus bx plus c plus b. Okay, here we can take a bracket. Now here a into derivative of quadratic function, but here integral of the type, it is a linear function upon under root quadratic function. Okay, and here it is a linear function is equal to a into derivative of quadratic function plus b. Here this expression, it is nothing but it is an adjustment of derivative of quadratic function in linear function. It is adjustment of derivative of quadratic function in linear function. Now here we can see it is a linear function upon quadratic function. We have already learned the examples of 1 upon under root quadratic function. 1 upon under root quadratic function. Okay. Now we can see the linear function upon under root quadratic function. Here adjust the derivative of quadratic function. We can write here, that is adjust derivative of quadratic function. Quadratic function, it is ax square plus bx plus c in linear function, that is px plus q. When we take a derivative of quadratic function, it becomes a linear function, because the derivative of quadratic function, that is a derivative of x square, it is in the form of x. Okay, derivative of x square in the form of x, that is the 2x. Okay, that means the derivative of quadratic function, it is a linear function, that is the derivative of quadratic function, the degree of derivative of quadratic function and degree of this linear function are the same. And then we know that in our lecture number 6, if degree of numerator and degree of denominator is same, then adjust denominator as it is in a numerator. Same adjustment we can take here, but here degree of numerator and degree of denominator is not same. Okay, here it is under root quadratic function, we can adjust the derivative of under root quadratic function. Okay, here derivative of this quadratic function, we can adjust the derivative of quadratic function in linear function. Okay, now we see the examples on it. Examples, same procedure as the last method, that is the linear function upon quadratic function. Same procedure, we can take a derivative of this ax square plus bx plus c, and then we can adjust this derivative in a numerator. Then we get two integrals, and we can solve these two integrals separately. One integral in the form of f dash of x upon under root f of x, and one integral in the form of 1 upon quadratic function. Okay, now we can see the example. It is an example in the exercise 3.2c. Example, evaluate integral of 3x plus 4 upon under root 2x square plus 2x and plus 1 dx. Okay, now it is linear function upon under root quadratic function. Now let integral is equal to 3x plus 4 upon under root of 2x square plus 2x plus 1 dx. Okay, now the method is linear function. It is a linear function. 3x plus 4 is equal to a into derivative of quadratic function, that is 2x square plus 2x plus 1 and plus b. Therefore this can be written as 3x plus 4 is equal to a into 4x, it is a derivative of 2x square plus 2 and it is plus b. Okay, now therefore it is a 3x plus 4 is equal to 4ax plus 2a and plus b. Now compare the both sides. Okay, both sides are equal, therefore compare the coefficient of x and the constant. Compare coefficient of x and constant. Okay, we get it is 4a is equal to 3. See carefully, 4a is equal to 3, it is the coefficient of x, it is equation number 1, and the constant 2a plus b is equal to 4, it is equation number 2, and then by 1 we get a is equal to 3 by 4, and by 2 we get 2 into 3 by 4 plus b is equal to 4, and therefore b is equal to, see carefully, it is a 2 by 4, so it is a 3 by 2. Okay, 2 get cancelled, 3 by 2, therefore b is equal to 4 minus 3 by 2. b is equal to 4 and it is minus 3 by 2, and that is here 8 minus 3, that is 5 by 2. It is the value of b. Okay, a is equal to 3 by 4 and b is equal to 5 by 2. Therefore this linear function can be written as 3x plus 4 is equal to a 3 by 4 into derivative of the quadratic function, that is 4x plus 2 and plus b it is a 5 by 2. Linear function is equal to a into derivative of quadratic function plus b. Linear function is equal to a into derivative of quadratic function plus b. Now we replace this linear function by this term. Okay, therefore we get here, therefore our integral becomes 3x plus 4 replaced by 3 by 4 into 4x plus 2 plus 5 by 2 whole to the upon under root 2x square plus 2x plus 1 dx. Now this integrals becomes this. Okay, because we replace 3x plus 4 by, it is replaced 3x plus 4 by 3 upon 4, 4x plus 2 plus 5 by 2. Okay, now this is a plus, separate the denominator, integral of 3 by 4 into, it is a 4x plus 2 upon under root 2x square plus 2x plus 1 plus, it is a 5 by 2 upon under root 2x square plus 2x plus 1 dx. Okay, here we can only separate the denominator. Now separate the integrals. It is a 3 by 4, we can write in the outside of the integral, then 4x plus 2 upon under root 2x square plus 2x plus 1 dx plus 5/2 into integral of 1 upon under root 2x square plus 2x plus 1 dx. Now we get here two integrals. This is first integral and this is second. Now it is 1 upon under root quadratic function, and such type examples we are already learned, that is the 1 upon under root quadratic function. By completing square we can solve this integral. And now here again it is a linear function upon quadratic function. Linear function upon quadratic function. Okay. Linear function upon quadratic function. Here is also linear function upon quadratic function. But here we can solve the linear function upon quadratic function by using this method. Okay. But here this linear function, it is a derivative of quadratic function. Okay. This is a quadratic function and it is a derivative of that quadratic function. We can adjust the derivative of quadratic function in numerator. Okay. Here. Now it is f dash of x upon under root f of x. So here we can write directly, it is a 3/4. We know that f dash of x upon under root f of x, it is a 2 under root f of x. That is 2x square plus 2x and it is a plus 1. Plus it is a 5/2 as it is. It is 1 upon under root quadratic function. For the complete square, first take the coefficient of the x square, it is a 1. So we can common this under root 2. So it is under root 2 into integral of 1 upon, see carefully, it is x square plus x and plus 1/2 dx. Okay. Now here we can write the reason for the first integral. It is the integral of f dash of x upon f of under root f of x is equal to 2 under root f of x plus c. Here this we can use here. Now these two to get cancelled. We can write here it is a 3/2 as it is into under root of 2x square plus 2x and plus 1 plus it is a 5 upon 2 under root 2. 5 upon 2 under root 2. Now by completing square method, here we can write integral of 1 upon under root x square plus the coefficient of x, it is 1, half of 1, it is a 1/2. Okay. Therefore plus 1/4 minus, sorry, here we can write first plus x and then plus 1/4 minus 1/4 plus 1/2 dx. Now first term we can take as it is, 3/2 under root of 2x square plus 2x plus 1 plus it is a 5/2 under root 2 into integral of 1 upon, here it is a x plus 1/2 whole square, x plus 1/2, x plus and it is 1/2 whole square, and here plus 1/4. It is a calculation of this dx. Now we can use here, it is a 3/2 under root 2x square plus 2x plus 1 as it is plus 5 upon 2 under root 2, then 1 upon x, sorry, here under root, here 1 upon under root x square plus a square, it is x square and a square, 1 upon under root x square plus a square, it is a formula log of x plus under root x square plus a square. Then we can directly write it is log of x, that is x plus 1/2 plus under root of x plus 1/2 whole square and plus a square and plus c. Okay. Here now expand this under root, we get it is x square plus x plus 1/2. Okay. It is the last answer. One more step we can write here, expansion of this, and the expansion of this under root, it is x square plus x plus 1/2. Okay. You can write the one more step, it is a last answer, it is not a last answer. Okay. Expand this. Okay. Now here we can see the example linear function upon under root quadratic function. Here the method is 3x, that is a linear function, is equal to a into derivative of quadratic function plus b. Okay. This expression, it is nothing but it is an adjustment of derivative of quadratic function in linear function. Here we can solve. First find the value of a and b and put the value of a and b in this function. We can adjust directly by using our method in our lecture number 5. Okay, here, sorry, I think lecture number 6, that is the degree of numerator is equal to degree of denominator. Okay, here you can check, it is lecture number 5 or 6. Okay, here now we can directly adjust. See carefully this. Here the derivative of 2x square plus 2x plus 1 is equal to 4x plus 2. Okay, therefore our integral, we can adjust the derivative in the numerator, that is 4x plus 2. It is 4x plus 2, but in the numerator there is a 3x. So 4 get cancel and 3 get 1 to 3. Therefore multiply by 3 by 4. 4 cancel and we get 3. Now 3 by 2 into 2. Sorry, it is a 3 by 4 into 2. We get 3 by 2. So we can write here minus 3 by 2. And it is a plus 4. Okay, and whole to the upon. Whole to the upon, it is under root 2x square plus 4x plus 1 dx. And now it is a 3 by 4 into 4x plus 2 and it is a plus 5 by 2 upon under root 2x square plus 4x plus 1 dx. Okay, it is, we can directly adjust. Okay, adjust the derivative of quadratic function in linear function. It is a derivative of quadratic function, so degree of the numerator and derivative is the same, so we adjust this derivative in numerator. It is adjustment and we get this step is a directly this step. Okay, here this step becomes this. Okay, and we can directly write. Okay, and then last answer of this problem. Okay, last answer, here we expand this. We can write here last answer 3 by 2 under root of 2x square plus 2x plus 1 plus 5 upon 2 under root 2 log of x plus 1 by 2 and plus here x plus 1 by 2 and this under root x square plus a square, it is equal to this, it is equivalent to this, and it is this. Therefore we can write here under root of x square plus x and plus 1 by 2 and plus c. It is the last answer of this. Okay, here see carefully. Okay, check this. Now we see the next example, and next example can be directly adjust. Okay, we can't find the value of a and b. It is a lengthy procedure. We can direct this type. It is a directly adjust the derivative of quadratic function in linear function. Next, example number 5. Integral of 7x plus 3 upon under root of 3 plus 2x minus x square dx. Okay. Now we can solve this example. Here it is again linear function upon under root quadratic function. Let integral is equal to 7x plus 3 upon under root of 3 plus 2x minus x square dx. Now here the process is linear function is equal to a into derivative of quadratic function plus b. That means they adjust the derivative of quadratic function in linear function. We can directly adjust the derivative of quadratic function. Therefore, derivative of quadratic function, that is 3 plus 2x and minus x square. We can directly write this derivative is minus 2x and plus 2. Derivative of 3, it is a 0. It is derivative of this 2 and it is minus 2x. Therefore, minus 2x plus 2, it is a derivative. Now, we adjust this term in numerator. Therefore, our integral, it is minus 2x plus 2. See carefully, it is minus 2x plus 2, we can adjust in the numerator. But in numerator, there is 7x plus 3. Now, we can adjust, and such type of adjustment we can learn in our lecture number 6. Okay, see carefully the lecture number 6 and then this. Okay, now here it is a minus 2x, but we want to 7x, so we can multiply by minus 7 by 2. Here minus and 2 get cancelled, we will get 7x. But here when we multiply minus 7 by 2 into 2, then we get, it is a minus 7. So minus 7 get cancelled, it is a plus 7. Now we calculate this, we get only 7x and it is a plus 3 as it is. Okay, see carefully. Whole to the upon under root 3 plus 2x and minus x square dx. Now integral of minus 7 by 2 into minus 2x plus 2 and plus 10 whole to the upon under root 3 plus 2x and minus x square dx. Okay, see carefully. When we use the method linear function is equal to a into derivative of quadratic function plus b, then we get the value of a is minus 7 by 2 and value of b is equal to 10. Okay, and we can write this term. Okay, here, but find the value of a and b and then put the value. It is a lengthy procedure, it is a easy way. Okay, 2 step. Now we can separate this integral. It is minus 7 by 2 into minus 2x plus 2 upon under root 3 plus 2x minus x square plus 10 upon under root 3 plus 2x minus x square dx. Okay, we can only separate the denominator. Now we can separate the integral, that is minus 7 by 2 into integral of, it is minus 2x plus 2 upon under root of 3 plus 2x minus x square dx plus 10 into integral of 1 upon under root 3 plus 2x minus x square dx. Okay, now we get the two integrals. See carefully, and these two integrals, it is f dash of x upon under root f of x. Okay, here under root f of x, the derivative of 3 plus 2x minus x square, it is minus 2x plus 2. That means it is f dash of x upon under root f of x. And we know the integral of f dash of x upon under root f of x, it is a 2 under root f of x, and it is 1 upon under root quadratic function. By completing square, we can solve this integral. Now integral is equal to, it is minus 7 by 2 into 2 under root f of x, it is 3 plus 2x minus x square plus 10 into integral of 1 upon under root, we can completing square, it is 3 plus 2x minus x square. The coefficient of x, it is a 2, half of 2, it is 1, and square of 1, it is 1. So here plus 1 minus 1, 3 plus 1 minus 1 plus 2x, and it is minus x square. Okay, to find the first integral, we use integral of f dash of x upon under root f of x is equal to 2 into under root f of x plus c. Now this 2 to get cancelled, it is minus 7 into under root of 3 plus 2x minus x square plus 10 into integral of, see carefully here, 1 upon under root 4, and we can take minus common in these 3 terms because the square term is negative. So it is a minus get common plus x square minus 2x and plus 1 dx. Okay, we can take minus common in these 3 terms. Then minus 7 into under root of 3 plus 2x minus x square plus 10 into integral of 1 upon under root 2 square minus x minus 1 whole square dx. It is x minus 1 whole square. Now here 1 upon under root a square minus x square, it is sin inverse x by a. First term as it is, minus 7 into under root of 3 plus 2x minus x square plus 10 into sin inverse of x by a, sorry, sin inverse of x, it is x by a and plus c. It is the last answer. Okay, here it is a linear function upon quadratic under root quadratic function, and then it is the last answer. Now we see the next example. Example number 6. Integral of under root x minus 7 upon x minus 9 dx. Now here see carefully, here integral, let I is equal to integral of under root x minus 7 upon x minus 9 dx. Okay, here we see in this lecture the integrals of the type linear function upon under root quadratic function. Okay, in the numerator there is only linear function, not under root linear. Okay, linear function, and in the denominator there is under root quadratic function. Okay, but here under root of linear function upon linear function, here we have already learned the examples in this type. Okay, here it is without under root x minus 7 upon under root x minus 9 in our lecture number 7. That is the examples in the form f of x upon g of x to the power n. Here power n is a 1 by 2 dx. Here degree of f of x, and it is a degree of g of x. Okay, degree of g of x, not power n. It is only degree of g of x and degree of f of x are same. Then we adjust this g of x in f of x. Okay, here x minus 7 upon under root x minus 9, then we adjust this x minus 9 in x minus 7 and we can solve. Okay, such type examples we are already learned in our lecture number 7. Okay, see carefully the lecture number 7, but here we can ask the question in this type. Okay, here under root of x minus 7 upon under root of x minus 9. Okay, see carefully this. Okay, and we know that, we know the type of the integral, it is a linear function upon under root quadratic function. So we can remove the under root in the numerator. So we multiply numerator and denominator by under root x minus 7. Okay, here see carefully this. The given integral is x minus 7 upon under root x minus 9. We multiply numerator and denominator by x minus 7. upon under root x minus 7 dx. Here multiply numerator and denominator by x minus 7. Then we get the integral under root x minus 7, under root x minus 7, it is x minus 7. But in the denominator, there is a multiplication of these two linear factors, okay, in the under root. X minus 9 into x minus 7. Therefore, it is x square. Minus 9 minus 7, it is a minus 16x and plus 63 dx, okay. It is a multiplication of these two terms, okay. And now it is linear function upon under root quadratic function. Now this example is in our type, and the solution method is adjust the derivative of quadratic function in linear function. Here, adjust the derivative of quadratic function in linear function. See carefully here. Derivative of x square minus 16x plus 63. Okay. Here, derivative of x square, it is a 2x and minus 16. Okay. Then we adjust this term, this derivative in the numerator. So it is a integral is equal to, it is 2x minus 16. See carefully. 2x minus 16. But it is only x. So we can multiply by 1 by 2. When we multiply 1 by 2, it is x. But it is minus 8. But we want to minus 7. So we can write it is a plus 8 and it is minus 7 upon under root of x square minus 16x plus 63 dx. Okay, here. When we multiply by 2, it is x and it is minus 8. But we want to minus 7. Okay, here minus 8. We want to minus 7. We can directly write here plus 1. Okay, but it is a procedure. Here minus 8. We can cancel the 8. That is the plus 8. And write the minus 7. And then we can write the calculation. It is a plus 1. We can directly write direct plus 1. It is minus 8 and it is plus 1. We get minus 7. Okay, here. It is we can write the one more step. 2x plus, sorry, it is minus 16 and plus 1 upon under root x square minus 16 x and plus 63 dx. Now separate denominator for these two terms. Then integral is equal to 1 by 2 2x minus 16 upon under root x square minus 16x plus 63 plus 1 upon under root x square minus 16x plus 63 dx. Now separate the integrals. It is 1 by 2 into 2x minus 16 upon under root x square minus 6x plus 63 dx and plus integral of 1 upon under root x square minus 16x plus 63 dx. Now here we get the two integrals. It is f dash of x upon under root f of x and it is 1 upon under root quadratic function. This is 2 under root f of x and it is by completing square method we can solve the integral. Now 2 into, sorry, here 1 by 2 constant as it is. Now here 2 into under root x square minus 16x and plus 63 plus integral of 1 upon under root x square minus 16x. The coefficient of x, it is a 16. Half of the 16, it is 8. And the square of 8, it is a 64. Therefore, plus 64 minus 64 plus 63 dx. And then here 2 to get cancelled. The first term is x square minus 16x plus 63 plus into integral of 1 upon under root of, it is x minus 8 whole square, and here minus 1 dx. Then first term as it is, under root of x square minus 16x plus 63 plus 1 upon under root x square minus a square, it is log of x plus under root of x square minus a square and plus c. And last answer, under root of x square minus 16x plus 63 plus log of, it is x minus 8 as it is, and plus under root of the expansion of this bracket, it is x square minus 16x plus 63 expansion. This term means this means this, and this is equal to this. Therefore we can directly write x square minus 16x and plus 63 plus c. Okay, it is the last answer of this term. Now we can see the next example. Now next, example number 7, integral of under root 9 minus x upon x dx. Here it is the same as the last example. Let integral is equal to under root of 9 minus x upon x dx. Okay, so we multiply numerator and denominator by under root 9 minus x. Therefore we can write under root 9 minus x upon x, sorry, it is under root x, into under root 9 minus x upon under root 9 minus x. Okay, now when we multiply, it is a 9 minus x and upon under root of 9x minus x square dx. And now it is linear function upon under root quadratic function. So we adjust the derivative of quadratic function in linear function. Now it is integral. Here derivative of 9x minus x square is equal to 9 minus 2x, it is a derivative. Okay, now this derivative we adjust in this term. Therefore here integral is equal to 9 minus 2x, but here variable it is only minus x and here minus 2x, so we multiply by minus 1 by 2, sorry, it is 1 by 2. Okay, when we multiply 1 by 2, here it is a minus x, but here it is a 9 by 2, but we want only 9. Okay, here it is a 9 by 2, so we can minus 9 by 2. When we calculate this term, we get only minus x and it is a plus 9. We can write here plus 9 whole to the upon under root 9x minus x square dx. Now it is 1 by 2 into 9 minus 2x and here plus 9 by 2 upon under root 9x minus x square dx. Now we can separate this denominator to both the terms. Therefore integral is equal to, okay, here we can separate 1 by 2 into 9 minus 2x upon under root 9x minus x square plus 9 by 2 upon under root 9x minus x square dx. We can only the separate denominator. Now we can separate the integrals. Here 1 by 2 into integral of 9 minus 2x upon under root 9x minus x square dx plus 9 by 2 into integral of 1 upon under root 9x minus x square dx. Okay. Now here it is f dash of x upon under root f of x, and it is 1 upon under root quadratic function. Okay. Now it is 1 by 2 into 2 under root f of x 9x minus x square plus 9 by 2 into 1 upon under root. Here coefficient of x it is 9, half of 9 it is 9 by 2, and the square of 9 by 2 it is a 81 by 4. So plus 81 by 4 minus 81 by 4, it is plus 9x minus x square as it is dx. Then it is 1 by 2, 2 get cancelled. Here it is a 2 into under root, sorry, only under root 9x minus x square plus 9 by 2 into integral of 1 upon, see carefully, 81 by 4, and we take minus common in the three terms, that is x square minus 9x and plus 81 by 4 dx. Then it is first term as it is, that is 9x minus x square plus 9 by 2 into integral of 1 upon under root, here it is a under root 9 by 2 whole square minus x minus 9 by 2, x minus 9 by 2 whole square dx. Now here we can use under root of a square minus x square. Then it is first term as it is 9x minus x square plus 9 by 2 into 1 upon under root of, sorry, we can directly integrate 1 upon under root of a square minus x square. It is sine inverse of x upon a and plus c. And now the last answer is 9x minus x square plus 9 by 2 sine inverse of 2x minus 9 upon 9, 2 to get cancelled, plus c. It is 2x minus 9 upon 2, and upon 2 get cancelled, sorry, yes, it is a 9. It is a last answer. Okay, here these examples are the linear function upon under root quadratic function. Okay, here in this lecture we can see the examples on linear function upon quadratic function. It is a exercise 3.2c. okay, but in the exercise 3.2b the such type examples are in this exercise. We can solve the examples in the exercise 3.2b. okay, in the same type. Here examples in the exercise 3.2b. 3.2b, example number 7, evaluate the integral under root of 9 plus x upon 9 minus x dx. Example number 8, under root of 2 plus x upon 2 minus x dx. And example number 9, it is integral of under root 10 plus x upon 10 minus x dx. Okay, the same examples. Okay, and the process is same as the last example. Okay, here we can solve the ninth example. Okay, here. Okay, we can solve the ninth example. Let integral is equal to under root of 10 plus x upon 10 minus x dx. Now here again we multiply a numerator and denominator by 10 under root 10 plus x. So we get here under root 10 plus x upon under root 10 minus x into under root 10 plus x upon under root 10 plus x dx. And then this becomes 10 plus x upon under root of 10 square, that is 100. Okay, we can also write it as a 10 square because a minus b, a plus b, it is a 10 square minus x square dx. Okay, it is a 100. 10 into 10, 10 a square minus b square, it is a minus b, a plus b, we can take the product. Now here it is a linear function upon under root quadratic function, so we can adjust the derivative of quadratic function in linear function, and the derivative of quadratic function, it is minus 2x, it is minus 2x, it is a derivative. Okay, but here only x, so we multiply by minus 1 by 2 and it is a plus 10 as it is. See carefully. Okay, here it is a linear function upon under root quadratic function. We can adjust the derivative of quadratic function in linear function, and the derivative of quadratic function, it is a minus 2x. We can adjust the minus 2x, it is minus 1 by 2, it is plus 10 as it is. Okay, then the calculation of this term, it is a 10 plus x, and in denominator same term, it is a 10 square minus x square dx. Now separate the denominator. Separate the denominator, it is minus 1 by 2 minus 2x upon under root 10 square minus x square plus 10 upon under root 10 square minus x square dx. Then we can separate the integrals, that is minus 1 by 2 integral of minus 2x upon under root 10 square minus x square dx and plus 10 into integral of 1 upon under root 10 square minus x square dx. And now here we can use f dash of x upon under root f of x and 1 upon sin in 1 upon under root a square minus x square. So we can write here minus 1 by 2 into under root of 10 square minus x square plus 10 into sin inverse of x by a, that is x by 10 plus c. Here we can use integral of f dash of x upon under root f of x dx. It is 2 under root f of x, okay, plus c, and we can use 1 upon under root a square minus x square dx. It is sin inverse x by a plus c. It is c1 and c2, then both plus c1 plus c2, it is a c. Okay, now here we can use these two formulas, then, and the last answer, it is 2 to get cancel, it is minus under root 100 minus x square, 100 minus x square, and minus, sorry, it is plus 10 sin inverse x by 10 and plus c. It is a last answer. We can use these two formulas, okay, in these two terms. Okay, see carefully this. Okay, and the example number 7 and 8 are same as this example. Okay, here example in the form of this, we can reduce it into linear function upon under root quadratic function, and the process of the finding the types of the integral, that is a linear function upon under root quadratic function, it is the adjust the derivative of quadratic function in linear function. Okay, and after adjustment we get the two integrals, that is one integral is f dash of x upon under root f of x and one integral is 1 upon under root quadratic function. We can solve both the integrals separately and we get the answer.